Why you were waiting, let's go. Right now, at this very second, something in the universe is sending a signal. It's not random noise, it's not a glitch, it's a structured burst of energy that traveled billions of light years to reach us. And in 2025, scientists detected the brightest one ever recorded. It released more energy in a single millisecond than our sun produces in 4 days. They nicknamed it RB float, the radio brightest flash of all time. And after monitoring that same spot in the sky every single day for 6 years straight, they had never seen it before. It fired once, then went silent. But that's just one of them. Over the past 5 decades, telescopes around the world have captured signals from deep space that no one can fully explain. Some repeat like a heartbeat, some vanish after a single pulse, some come from places where nothing should exist. And one of them, detected in 1977, still has no confirmed explanation after nearly 50 years. Signal 10, the Lorimer burst, the one that started it all. In 2001, a radio telescope in Australia called Parkes Observatory recorded something strange, a single intense burst of radio waves that lasted less than 5 milliseconds. It came from outside our galaxy, from billions of light years away, but nobody noticed. The data sat in an archive untouched for 6 years. In 2007, astronomer Duncan Lorimer and his student David Narkovich were digging through that old data when they found it, a signal so brief and so powerful that it seemed impossible. Nothing known in astrophysics at the time could explain a burst of radio energy that intense, that short, and that distant. The scientific community was skeptical. Many thought it was a glitch, an equipment error, or interference from Earth. In fact, similar-looking signals had already been found and traced back to microwave ovens in the observatory's kitchen. Those false signals were called peritons, so many astronomers simply dismissed Lorimer's discovery as another one. But Lorimer was right. His burst was real. It came from a galaxy billions of light years away, and it released in a fraction of a second more energy than our sun emits in 3 entire days. Today, we call these events fast radio bursts, or FRBs, and since Lorimer's discovery, we've detected over 4,000 of them. They pop off across the sky like camera flashes at a stadium. But what creates them? That question is still not fully answered, and the deeper we look, the stranger the answers get. Signal 9, the repeater, FRB 121102, the signal that came back.
Most fast radio bursts fire once and never return, but in 2012, a signal was detected that broke the rules.
FRB 121102 was found by the Arecibo Observatory in Puerto Rico, and unlike every other FRB at the time, it came back, again and again. Over 300 bursts have been recorded from this single source. In 2017, astronomers finally traced it to a tiny dwarf galaxy about 3 billion light-years away. The source is embedded in an extreme magnetic environment, far more intense than anything we encounter in our own galaxy, and the bursts follow a roughly 157-day cycle, like a slow cosmic heartbeat, active for about 90 days, then silent for 67 days, then active again. What could produce this pattern? The leading theory points to a magnetar, a neutron star with a magnetic field a trillion times stronger than Earth's. These objects are only about 20 kilometers across, but contain more mass than our sun. Their magnetic field lines can snap and reconnect with unimaginable force, releasing bursts of energy that outshine entire galaxies for a millisecond. But here's what makes FRB 121102 truly strange. In January 2026, a study published in Science revealed that researchers using China's FAST detected what they call an RM flare, a sudden and extreme shift in the polarization of the radio signal from a repeating FRB. This shift is consistent with material from a coronal mass ejection, basically a stellar explosion from a nearby companion star passing through the region around the FRB source. Professor Bing Zhang of the University of Hong Kong, one of the study's corresponding authors, said the evidence strongly supports a binary system containing a magnetar and a companion star. If confirmed, it means some of these signals aren't coming from lone objects in space. They're coming from cosmic partnerships, 2 stars, one dead and one alive, locked in an orbit that produces the most powerful radio flashes in the universe. Signal 8, RB float, the brightest flash of all time. March 16, 2025, the Chime radio telescope in British Columbia, Canada, detected something so bright that astronomers initially weren't sure if it was a real signal or just a burst of cell phone interference. It was real, and it was extraordinary. The signal, officially named FRB 20250316A, but nicknamed RB float for Radio Brightest Flash of All Time, came from the spiral galaxy NGC 4141 in the constellation Ursa Major, about 130 million light-years away. That's cosmically close, and it released as much energy in less than 1 second as our sun produces in 4 entire days. What makes RB floats so important isn't just its brightness, it's what happened before and after. The CHIME telescope had been monitoring that exact patch of sky every single day for over 6 years, thousands of passes. Not a single burst was ever detected from that location. Then, without warning, the brightest fast radio burst in recorded history went off, and it hasn't repeated since. This challenges a major assumption in astrophysics. Many scientists believe that all FRBs eventually repeat, that they're all produced by the same type of source, but RB float suggests otherwise. If some bursts are truly one-time events, they may be caused by catastrophic processes, collisions, collapses, or explosions that destroy the source entirely. Using the newly operational CHIME outrigger telescopes, a transcontinental array stretching from British Columbia to West Virginia, the team pinpointed RB float's origin to a region just 45 light-years across. Then, NASA's James Webb Space Telescope zoomed in. It found a faint infrared source near the burst location, possibly a red giant. If a neutron star is siphoning material from that red giant, the gravitational interaction could be what triggered the burst. Kiyoshi Masui, associate professor of physics at MIT, said, "Cosmically speaking, this fast radio burst is just in our neighborhood, and we still don't know what caused it. The brightest signal ever detected from deep space, and it left no explanation behind." Signal 7, FRB 20240209A, the signal from a dead galaxy. In January 2025, astronomers announced a detection that broke the pattern even further. FRB 20240209A was traced to the outskirts of a massive ancient elliptical galaxy about 2 billion light-years away. This galaxy is over 11 billion years old, and it's dead. No new stars have formed for billions of years. This is a problem because the leading explanation for fast radio bursts requires magnetars, and magnetars form from the deaths of young, massive stars. In a galaxy where star formation ceased billions of years ago, there shouldn't be any magnetars left. They burn out within about 10,000 years. Vishwangi Shah, a doctoral student at McGill University who led the analysis, said this FRB is not only the first to be found outside a dead galaxy, it's also the farthest from its host galaxy of any known FRB. The burst came from the galaxy's outermost edge, possibly from a globular cluster, a dense ball of ancient stars. If this is confirmed, it means FRBs can arise through entirely different mechanisms than we thought, perhaps through the merger of two ancient compact objects, perhaps through processes we haven't even theorized yet. A signal screaming from a graveyard of dead stars, from a galaxy that should have nothing left to send.
Signal 6, the WOW signal, 48 years of silence. August 15, 1977, the Big Ear radio telescope at Ohio State University was scanning the sky as part of the longest-running SETI program in history. At 11:16 p.m. Eastern Time, the telescope recorded an extremely powerful narrowband radio signal lasting 72 seconds. It appeared to come from the direction of the constellation Sagittarius, near the galactic center. A few days later, astronomer Jerry Emin was reviewing the printout of data. When he saw the signal's intensity values, 6EQUJ5, representing a signal 30 times stronger than the background noise, he circled them and wrote one word in red ink: "Wow." The signal had every characteristic that scientists expected from an extraterrestrial transmission. It was narrowband at the frequency of neutral hydrogen, 1,420 megahertz, a frequency protected internationally because of its scientific importance. No aircraft, no satellite, no known terrestrial source could have produced it, and it has never been detected again. Not once, despite hundreds of follow-up observations over nearly 5 decades. In August 2025, Abel Mendez and his team at the Planetary Habitability Laboratory published the most comprehensive reevaluation of the WOW signal to date, using decades of previously unpublished Ohio SETI data retrieved from archives. Their analysis refined the signal's potential origin to a much narrower and slightly displaced position from earlier estimates. They also found several similar but much weaker signals in the archival data, all consistent with a rare astrophysical event, radiation from a distant transient source exciting a cloud of neutral hydrogen, making it glow intensely for several minutes. Is this the answer? Maybe. But even Mendez acknowledges the explanation is not confirmed. The WOW signal remains, 48 years later, one of the most tantalizing unexplained radio transients in the history of science. Either it was a 1 in a billion natural alignment that we happened to catch at the exact right moment, or something else sent it. Signal 5, BLC-1, the signal from the nearest star. In 2019, the Parkes Observatory in Australia was studying Proxima Centauri, the closest star to our solar system, at only 4.2 light-years away. The telescope was being used by Breakthrough Listen, a $100 million SETI project funded by tech billionaire Yuri Milner. Buried in the data was something unusual, a narrowband signal at exactly 982.002 megahertz, needle sharp. It appeared in 5 of the 30-minute observations over a 30-hour period, and it seemed to come from the direction of Proxima Centauri. A young intern named Shane Smith discovered the signal in late 2020 while reanalyzing the 2019 data. It was given the designation BLC-1 for Breakthrough Listen Candidate 1. Sophia Sheikh of Penn State University led the analysis and called it the most exciting signal Breakthrough Listen had ever found. It passed more of their interference filters than any previous candidate. The signal showed a slight Doppler drift, the kind you'd expect from a transmitter on a rotating planet. It was narrow band, a hallmark of artificial technology, and crucially, when the telescope pointed away from Proxima Centauri, the signal disappeared. When it pointed back, the signal returned. But then, deeper analysis found the same signal at slightly different frequencies during periods when the telescope was not pointing at Proxima Centauri. 15 additional detections that pointed to a terrestrial source, likely a form of Earth-based radio interference. BLC-1 was almost certainly not alien, but here's the uncomfortable truth. The investigation took over 2 years, and the team could never definitively identify the exact source of the interference. We know what it probably wasn't. We don't know exactly what it was. And it came from the direction of the closest star system to Earth, one that hosts at least 2 planets, including Proxima Centauri b, which orbits in the habitable zone. If you're still here and these signals are making you question everything, take 1 second and hit the like button. It helps the channel grow and means I can keep making deep research content like this. Now let's keep going because the next 5 signals get even stranger. Signal 4. SGR 1935 plus 2154, the first FRB from inside our own Milky Way galaxy. On April 28, 2020, something unprecedented happened. For the first time ever, a fast radio burst was detected coming from inside our own Milky Way galaxy. The source was a magnetar called SGR 1935 plus 2154, located about 30,000 light-years away in the constellation Vulpecula. The burst, designated FRB 200428, was detected simultaneously by the CHIME telescope in Canada and the STARE-2 experiment in the United States. It lasted about a millisecond, and while it was thousands of times weaker than extragalactic FRBs, its comparative proximity made it one of the most powerful radio events ever observed from within our galaxy. This detection was the first direct link between fast radio bursts and magnetars. Before this moment, the magnetar hypothesis was educated speculation. After this, it became the leading model. But there's a catch. FRB 200428 was accompanied by an X-ray burst from the same magnetar. Not all FRBs show X-ray counterparts, and the energy of this galactic burst was still far below the most powerful extragalactic FRBs. So while magnetars are clearly one source of fast radio bursts, they may not be the only source. The monster in our backyard gave us a clue, but not the complete answer. Signal 3 FRB 20220912A, the sad trombone from outer space. In late 2022, a fast radio burst source called FRB 20220912A became temporarily hyperactive, emitting thousands of bursts over a period of just a few months. Astronomers at the SETI Institute used the Allen telescope array to record thousands of these bursts in unprecedented detail. And when they converted the radio frequencies to audio, something remarkable emerged. Each successive burst dropped slightly in central frequency, creating a sound that researchers described as a cosmic sad trombone, a sliding note descending in pitch, burst after burst. This downward frequency drift is not random. It suggests a physical process happening at the source, possibly a neutron star's magnetosphere relaxing after each burst, or plasma cooling and falling back toward the surface. The pattern provides a direct window into the physics of whatever engine is producing these signals. No one fully understands why the frequency drops, but the pattern is too consistent to be coincidence and too structured to be noise. The universe is sending a signal that, when you listen to it, sounds like something winding down, like an instrument playing its final notes. Signal 2, 3I/Atlas, the Interstellar Visitor's Radio Whisper. On July 1, 2025, astronomers detected a fast-moving object racing toward our sun. It was named 3I/Atlas, and orbital analysis quickly confirmed something extraordinary. It came from outside our solar system, only the third interstellar object ever detected near Earth. And it was moving at 245,000 kilometers per hour, the fastest known object ever observed within the solar system. Unlike the two previous interstellar visitors, 1I/Oumuamua in 2017 and 2I/Borisov in 2019, Comet 3I/Atlas arrived large enough and bright enough for detailed study. When it disappeared behind the sun during perihelion, ground-based telescopes lost sight of it, and NASA and ESA spacecraft took over observations. Analysis revealed higher than expected levels of carbon dioxide and nickel in its composition. But on October 24, 2025, shortly after the comet emerged from its solar pass, astronomers detected a radio signal coming from 3I/Atlas, specifically the hydroxyl radical emission at radio wavelengths, a signature of cometary outgassing as ice sublimates. This was the first radio detection of an interstellar comet. Now, was this an alien communication? No. The scientific consensus is clear. 3I/Atlas is a comet, not a spaceship. But what made it controversial was Harvard astrophysicist Avi Loeb, who had previously claimed that 1I/Oumuamua might be an alien probe. Loeb tracked 3I/Atlas closely, analyzing its non-gravitational acceleration, its unusual brightness changes, and the anomalous characteristics of its trajectory. The interstellar comet also sprouted an unusual feature, a short plume pointing toward the sun called an anti-tail, which turned out to be a real physical phenomenon, not an optical illusion. Two spacecraft, including NASA's Europa Clipper, passed directly through the comet's tail. 3I/Atlas will remain visible into spring 2026 as it heads back out into interstellar space. Astronomers will continue studying its composition and behavior. And while it is overwhelmingly likely to be a natural object, it remains a reminder that things from between the stars do visit us, and one day, one of them might not be a comet. Signal 1, the SETI at Home finale, 12 billion candidates and counting. And signal number 1, not a single signal, but 12 billion of them. In the mid-1990s, scientists at the University of California, Berkeley, launched a project called SETI at Home. The idea was simple but revolutionary. Let ordinary people donate their computer's processing power to analyze radio telescope data for signs of alien intelligence. They expected maybe 50,000 volunteers. Within a year, over 2 million users in 100 countries had signed up. It became the largest distributed computing project in history. For over 2 decades, SETI at Home processed data recorded by the Arecibo Observatory in Puerto Rico before its tragic collapse in 2020. The project focused on signals near the radio wavelength of 21 centimeters, the frequency of neutral hydrogen. This is the wavelength astronomers routinely use to map hydrogen gas in the galaxy. The sheer volume of data was staggering. Over the course of the project, volunteers processed enough data to identify 12 billion signals of interest.
In 2025, papers published in the Astronomical Journal, project leader Anderson and his colleagues described how they analyzed this vast dataset. Using a supercomputer provided by the Max Planck Institute for Gravitational Physics in Germany, they eliminated billions of false positives and Earth-based radio interference, narrowing the pool to 1 million candidates. Then they manually analyzed the top 1,000 and finally distilled the list to 100 of the most promising contenders. Those 100 signals are now being re-examined using the world's largest fully steerable radio telescope, the Green Bank Telescope in West Virginia. These are signals that passed every automated filter, signals that don't match any known natural or terrestrial source, signals that, at least statistically, behave the way an alien transmission might be expected to behave. Has SETI at home found aliens? We don't know yet. The final analysis is ongoing. But consider the magnitude of what happened. Over 2 million ordinary people working across national borders, languages, and time zones volunteered their own computers to search for a signal from another civilization. They processed more data than any single institution could have handled alone. They turned alien hunting from a niche scientific pursuit into a global citizen science movement. And now, after 2 decades of work, 100 signals remain unexplained. Out of 12 billion candidates, 100 passed every test. Whether those signals turn out to be natural, artificial, or something we haven't imagined yet, the search itself is already one of the most extraordinary signals humanity has ever sent. A signal that says we're here, we're curious, and we're listening. If these signals made you question what's out there, subscribe and hit the notification bell. Don't forget to like this video and tell me in the comments which signal disturbed you the most. Was it the wow signal's 48 years of silence, RB Float's single devastating flash, or the 100 unexplained candidates from 12 billion? See you in the next one.